Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to configure Google Coral USB Accelerator with Raspberry Pi 4 using latest Raspberry Pi OS bookworm for TensorFlow Lite. In last session we configure Google Coral USB Accelerator for YOLO V8, and in this session we are going to configure Google Coral USB Accelerator for TensorFlow Lite on latest Raspberry Pi OS bookworm 64-bit version. So before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, for that first we need our repository. I will mention the link inside description box. You need to simply copy paste the link inside the browser. Then go to the code. Here code, click on download zip, and it will download our zip format repository. As you can see, we successfully download our repository. Now open file manager, go to the downloads, and this is what our zip format repository. Right click to the repository and click on extract here. It will extract our repository. Then we need to move our repository in home folder. So right click, then simply click on cut, go to the home folder and just paste our repository. That's it. Now open our repository, and here you will see we have here install steps. This is simple text file. Just right click to the install steps text file, open with text editor. As you can see, open with text editor. It will open our file as a text editor. This is what our text editor, and this is what our file install steps. So this is the steps which we are going to follow for installing virtual environment. Also we are going to install here Python 3.9.12 for Coral USB, and then we are going to basically activate our virtual environment. Then we are going to install Google Coral USB Accelerator on Raspberry Pi 4 bookworm 64-bit version. Done. So let's just start. So open terminal and just copy the first command, which is sudo apt update. Copy it, open terminal and just paste as it is, and then hit enter. Sudo apt get update. Now it's updating our all the repository. Done. Now we are going to upgrade our packages. So just copy second command, sudo apt get upgrade, copy it, open terminal and then paste it and then hit enter. Then here simply we want to mention Y, so just press Y from keyboard and hit enter. So it will take some time for upgrading some packages. So meanwhile I will pause video. So friends, we have done with upgrade process. As you can see, we have completed upgrade process. Remember one thing friends, connect your Google Coral USB Accelerator with Raspberry Pi 4. And on Raspberry Pi 4 we have USB port 3.0. just connect your Google Coral USB Accelerator with USB 3.0. Simple. So I have already connect hardware with Raspberry Pi 4 on Raspberry Pi USB port 3.0. Done. So we have done with our upgrade process. Now our next command. So here as you can see, we are going to create now basically a virtual environment. So for that we are going to create a separate folder, or we can say we are going to create here a separate directory. So just open terminal, just clear the screen, clear, and just create here a directory, or you can say simply a folder. So for that we have our command mkdir space freedom tech, mkdir space, and mention the folder name or the directory name, freedom tech. Just hit enter. Now run cd space freedom tech, hit enter. Now we are inside our directory. So now here in this directory we are going to create our virtual environment. We are going to install Python 3.9.12 only for this particular directory. That's it. So now our third command, we already done with these two command, sudo apt get update and sudo apt get upgrade. Now we are going to run our third one command. So just copy it, copy, and as you can see we are inside our freedom tech directory. Just paste command here and then hit enter. Done. Now next command, fourth command, so just copy it from echo and shell. Echo, start from echo and end at the shell. Just copy as it is, copy it, open terminal and just paste the command and then just hit enter. That's it. Now we are going to install some packages. So fifth number command is basically install some packages. So just copy the command, copy it, open terminal and just paste as it is and then hit enter. So it will install all these basic packages which we need for Coral USB Accelerator. So it will take some time. Again, meanwhile I will pause the video. So friends, we have completed our package installation process. So our next command, we have done with fifth command. Our next command is sixth one. So just copy as it is from our text file, open terminal and just paste as it is and then hit enter. Now it will install Python 3.9.12 on for basically freedom tech directory. Simple. So it will take some time. Meanwhile I will pause the video. So friends, as you can see, we have successfully installed Python 3.9.12. Now our next command, so we have done with command number 6. So now this is command number 7. Just copy as it is, copy it, open terminal and then just paste it and then hit enter. Done. Now if you type here our 8 number command, Python version, here inside a freedom tech directory, if you hit enter, as you can see we have now Python 3.9.12 version only for freedom tech directory. If you go here file and if you open new tab, this is the new tab, and if you just come out from cd directory, if you come out from freedom tech directory, so we have now change our directory and we just type here pwd. So now we are inside /home/pi, and if you now here type, if you type here open terminal Python version command, then here you will see we have Python 3.11.2 version, because we are now outside from our freedom tech directory. As I mentioned, we create a virtual environment, for only for freedom tech directory. Also we install Python 3.9.12 only for freedom tech directory. So if you come out from the freedom tech directory and if you try to check the Python version, you will get the Python default version, which is Python 3.11.2. That's it. Done. Now simply we are going to activate our virtual environment. So here it is, as you can see. So we have done with installing Python 3.9.12. Now we are going to start our Google Coral USB installation process. So first command, just copy as it is. This is the first command, copy. It will activate our virtual environment. So just paste it and hit enter. So friends, as you can see, .venv, it means we successfully activate virtual environment. Now second command, so just copy it, second command, copy it, open terminal, and now we are inside our virtual environment. Let's just clear the screen and here paste our command, hit enter. Now third command, this one, copy as it is, open terminal, paste it, hit enter. Done. Now again fourth command, copy as it is, open terminal, just paste it, hit enter. Done. Now last command, fifth one command, which is install lib Edge TPU 1-std. So this is what our package for Edge TPU. Just paste it and then hit enter. Done, friends. So we successfully install our lib Edge TPU -std1 package. Now close all the things because we are going to simply reboot our Raspberry Pi 4. So just reboot Raspberry Pi 4, shut down and click on reboot. It will reboot our Raspberry Pi 4. So let me reboot the machine. So friends, I have reboot our Raspberry Pi 4. Now again open file manager and our repository, just open it. And now what we are going to do, simply open again our install steps file, text file with the help of text editor. So friends, as you can see, we have opened our file, text file. Now here again open terminal, go inside our Freedom Tech directory, cd space Freedom Tech, hit enter, and now again here run this command, this one, source.venv, which is for activating our virtual environment. This command, source.venv bin activate, just copy, open terminal and just paste it here, paste and then hit enter. As you can see, now we are inside our Freedom Tech virtual environment directory. Now we have done with install steps. Now what we want, we are going to simply install TensorFlow Lite for our virtual environment. For that, we have inside our repository, we have here, as you can see, this is the TensorFlow Lite bullseye. So this is basically zip format file. So just right click to this file, TensorFlow Lite bullseye main, right click and click on extract here. It will extract TensorFlow Lite bullseye main folder like this way, as you can see, and inside that we have TensorFlow Lite .sh bash script. So we want to move this folder inside our Freedom Tech folder. So this one, just cut the folder, go to the home, and this is what our virtual directory which we create, Freedom Tech. Open it and just paste our TensorFlow Lite bullseye main folder. Now just close it, and we are now here inside terminal. We are now inside our virtual environment Freedom Tech directory. So if you run here ls command, we just copy our folder TensorFlow Lite bullseye main. That's it. So now go inside this folder. So run the command cd space TensorFlow Lite bullseye main. This is what our folder, and then hit enter. Now here let me make a full screen of terminal and let me make more zoom in. I hope you all see clear. Now we are inside Freedom Tech folder, then TensorFlow Lite bullseye main. So if you type here ls command, as you can see, this is what our bash script, which basically upload our example folder, we can say. So for that we want to mention here full permission for this bash script. So run the command chmod space 775 and our bash script name, which is TensorFlow -lite.sh. Hit enter. Now if you run the command ls As you can see, the color is green. It means we change the permission. Now simply we want to run the bash script. So how we run bash script? Bash command space, mention our script name, which is in this case TensorFlow-Lite.sh, and then just hit enter. It will extract example folder inside our TensorFlow Lite bullseye main folder. So as you can see, reading packages list, and then here it is, as you can see, cloning into examples folder. It is basically cloning examples folder, and inside that examples folder we have all the requirements file for TensorFlow Lite for Python 3.9.12 version. Done. Now if you run command ls again, as you can see, now here we have examples folder, examples. Simple. Now what we want to do, just minimize terminal and go to the menu, programming, open Thony, because this is the bullseye version repository, or we can say the directory examples. So inside that we have requirements.txt file for TensorFlow Lite installation. So this is the old version file. So we have basically OpenCV Python old version. So we need a latest version. So we are going to check the latest version. So just go to the menu, programming Thony, and first, because this is completely fresh version, so just click on switch regular mode, click on OK, and then again close. Go to the menu again, programming Thony. It will open our Thony Python IDE, and then go to the tools, manage packages, and just search for OpenCV-Python, hit enter. OpenCV-Python, this is the package. Just click on it and just check the Python version, not Python version, sorry, just check the OpenCV-Python package version, which is 4.9.0. so this is the latest version, 4.9.0, which we want to mention. So just close all the things, close Thony Python IDE, and remember the OpenCV-Python latest version is 4.9.0. so just open file manager, our virtual directory folder, which is freedom tech. Inside that we have TensorFlow Lite bullseye main, again inside that we have examples folder, then we have Lite folder, then again we have example folder, then here we have object detection folder. As you can see, object detection, just click on it. Inside that we have Raspberry Pi folder, and then as I mentioned, we have here requirements.txt file, which require for installing TensorFlow Lite version. So right click and open with text editor, and here it is, as you can see, OpenCV-Python 4.5.3, which is the old version. So simply change with the latest version, which we just cross check. So our latest version is 4.9.0, so 4.9.0. Done. Just go to the file, click on save, that's it. Now we are ready, and we are going to simply install our TensorFlow Lite. So again, open our terminal, and we are inside our virtual environment, we are inside freedom tech folder, we are inside TensorFlow Lite bullseye main folder. Just clear the screen. Now if you run here ls command, we have our examples directory. So we want to go inside examples, then we want to go inside Lite and requirements, and then we have a setup.sh file. So run the command like this way: cd space first examples folder, then Lite folder, then again examples folder, then we have object detection. So just press OB and press tab button, it will auto complete the directory name, which is object detection, and then just hit enter. Now clear the screen. If you run here ls command, as you can see, we have here Raspberry Pi folder. So now we want to go inside our Raspberry Pi folder, cd space Raspberry Pi, ls command again, and here it is, as you can see, the requirements.txt file, where we change the OpenCV-Python version, which is the latest version 4.9.0. Now we want to run this setup.bash script, setup.sh. Again same way, bash space setup.sh, and just hit enter. Now it will install TF Lite on our virtual environment for Python 3.9.12 version. So it will take some time. Meanwhile, I will pause the video. So friends, as you can see, we successfully installed TF Lite on our virtual environment for Python 3.9.12 version. Done. Now simply what we want to do, just minimize the terminal and open our file manager again. Go to the Freedom Tech folder, which is our virtual folder. Then TensorFlow Lite bullseye main, examples, Lite, then again examples, object detection folder, this one, and then go to the Raspberry Pi folder, and here we have detect.py. So this is the default detect.py for normal TensorFlow Lite. So because we are using here Google Coral USB, so I have create basically I have mentioned some changes inside detect.py file. So I have mentioned the new detect.py inside our repository. So this is what our by default detect.py for inside Raspberry Pi folder. So we want to go again, we want to open our repository. So let me open file manager again. This is the second file manager, and this is what our repository, TF Lite Coral USB custom main. Open it, and here it is. As you can see, this is the detect.py file which I have mentioned. Means in this file I have mentioned some changes for Edge TPU device, a Google Coral USB Accelerator device. So we want to use this file instead of by default detect.py. So from /home/pi freedom tech TensorFlow Lite bullseye main examples Lite examples object detection Raspberry Pi folder, we have detect.py. So just rename this default file. So right click and mention detect1.py, and then copy our new detect.py from our repository. Just copy it and just paste here, paste it. Where we want to paste? We want to paste our new detect.py inside our Freedom Tech virtual folder. Inside our Freedom Tech virtual folder, we have TensorFlow Lite bullseye main folder, then we have example folder, then we have Lite examples object detection folder. Inside that we have Raspberry Pi folder, and inside that we have by default detect.py file which we rename as a detect1.py, and then just copy paste the new detect.py from our repository to here Raspberry Pi folder. As you can see, I have mentioned it. That's it. And inside that, this is the, as you can see, this one is basically default model for TF Lite, and this one, as you can see, Edge TPU.TF Lite, this is the by default model for object detection with Google Coral USB Accelerator using TF Lite. So we want to mention this model name inside our detect.py. So for that, first just minimize the file manager, minimize all these things, open again our terminal, clear the screen, and as you can see here we are inside our virtual environment. So let's just mention here cd and just come out from the Raspberry Pi directory, just come out cd. Clear? Now we are inside our virtual environment, and here what we want to do, just go inside Freedom Tech, our virtual directory, and here we want to run our Thony. So Thony, hit enter. It will open our Thony from our virtual environment, and then here go to the run config interpreter and Python. Here we want to change our Python version. So this one is default one, Python 3.11.2. We want to change with this one, /home/pi, our Freedom Tech, our virtual directory. Inside that we have our virtual environment, and inside that we have our Python 3.9 version. So select it, click on OK, and then here it is. As you can see, we change our version. Now we successfully changed the version inside Thony. So just close it from here, close it from terminal and close the terminal. Now there is no need to open our terminal and then open our Thony we simply open Thony Python IDE as we always open normal way. Just go to the menu, programming, Thony, and then you will see we have your Python 3.9.12. Suppose if you still see Python 3.11.2 or our default version, you can simply go here, run config interpreter, and just go here and you can simply select /home/py-freedom-tech virtual environment bin Python 3.9. It will change the Python version. Now we are ready and we are going to open our detect.py. So just go to the file, click on open, and our virtual directory, which is Freedom Tech. Inside home we have Freedom Tech, TensorFlow Lite bullseye main, examples, Lite, again examples, then we have object detection, then we have Raspberry Pi, and then we have detect.py. So this is what our detect.py. Inside that I have already mentioned all the changes for Edge TPU, and here I have mentioned, as you can see here, this is basically custom model which I have already created. So here we want to mention first, because first we are going to cross check our by default version, then I will show you how we can create our own custom model. But first let's just cross check with our default model. So our default model name is I need to go inside home, Freedom Tech, TensorFlow Lite bullseye, examples, Lite, and then examples, object detection, Raspberry Pi, and then this is the model. Right click to the model, rename. This, as you can see here, we have htpu.tflite. So just copy it, the name, cancel, close, and here we want to mention our model name default. Just remove this one, remove it, and just press Ctrl+V. It will copy paste our htpu.tflite default model name, and then just run the code. So I have connect here USB web camera. It will start my USB web camera, and then we have object detection with Google Coral USB Accelerator. As you can see, friends, it's detecting me as a person, and we successfully configure our Coral USB Accelerator, and we are detecting object. So let me stop a webcam. So when you start the code, you will see in our Coral USB Accelerator we have white color light which basically start blinking. So as you can see, it's detecting me as a person. So this is the default version, this is the default model for detecting objects, for detecting our objects. So we successfully configure Google Coral USB Accelerator. We configure here our virtual environment. We install Python 3.9.12 version. Then we basically activate the Python 3.9.12 version inside our Thony, and then we start our detect.py. So we basically replace our default detect.py with new detect.py, which I have mentioned inside the repository. We rename our default detect.py as a detect1.py, and then we mention default model name, and then we start our code. And because I have here a USB web camera which I have connect with the Raspberry Pi 4, of course it will start USB web camera, and then we have object detection with the help of Google Coral USB Accelerator. Done. So this is for default model. Now we are going to create our own custom model for Coral USB Accelerator. So let's just start. For that, first we want to install label IMG software. So just close all these things. Close it, and again open file manager. Again we want to go inside our repository, and here we have label img.sh file. But first we want to run some command, only one command. So here we have rpi4.txt file. Just this is the normal text file. So just right click and open as a text editor, and this is the first command. As you can see, first one. So just copy as it is, copy it, open terminal, and we are going to install here our label IMG software. So for label IMG software, there is no need to activate our virtual environment. Here it is, as you can see, this is the normal environment where we have our Python by default version, Python -- version, which is Python 3.11.2. So here, as you can see, I have deactivated basically our virtual environment. How we deactivate? Just close the terminal and open again new terminal, or you can simply open new tab. Then you have basically new environment. Simple. So this is the by default environment where we have Python 3.11.2 version. So here we want to run the first command, this one, from rpy4.txt file, a text file. So just copy it, open terminal and then paste it, hit enter. Done. Now we are ready, and just close the text file, and here this is the terminal. Let me make full screen, and if you run here ls command, this is what our repository, TF Lite Coral USB custom build. So we want to go inside our repository, so cd space TF Lite, just press tab, it will auto complete our repository name, hit enter, ls command, and then we have here label img.sh bash script, which basically install label img. So we want to mention the full permission for label img.sh. Same way, chmod command, so chmod space 775 and space our label img.sh bash script. So chmod space 775 and mention the bash script name, which is label img.sh. So if you run here again ls command, the script is now in green color, means we successfully changed the permission. Now we are ready and we are going to run our bash script. So bash is the command space our script name, which is label img.sh, and then hit enter. It will install label img on our latest Raspberry Pi bookworm 64-bit version. So it's now installing. So friends, as you can see, successfully installed label img. So now if you clear the screen and just run the label img command, so lab and press tab button, it will auto complete our command. This one, as you can see, label and I is basically capital. So labe, and if you press the tab button, it will auto complete command, hit enter. It will open our label img software. And as you can see, we successfully install our label img. Just close it. Now, as I mentioned, we are going to create our own custom model which detect Arduino Uno. You can detect any custom object as per your requirements. So today we are going to detect here Arduino Uno board with the help of TF Lite using our Google Coral USB Accelerator. So for that we need photos, or we can simply say we need images. So we are going to collect our images with the help of our USB web camera using our img.py code. So simply minimize the terminal and open programming Thony Python IDE, and here again we are going to change our version. So this is the default version. Let me close detect.py, go to the run config interpreter, and then here we are going to change our default version. So now we change our version with our default one, which is Python 3.11.2, and now go to the file, click on open, go to the home and our repository, and here we have img.py. Open it. So as you can see, I have mentioned here USB web camera. We are going to capture here 30 frames. You can simply change the number. You can mention here 130 images, you can mention 1000 images. So for today's session I will capture only 30 images. 30 images of Arduino Uno board using this img.py. And then here we want to mention our images folder path. So let's just create images folder. So open our repository. This is what our repository, and create here images folder. Right click, new folder, images, click on OK. Right click to the images folder, copy the path, open our img.py and just remove it from Google Coral USB main. Just remove it from, sorry, not Google Coral USB main, friends. Just remove it from images. Images, go back. From images, just go back. Go back, back, and then stop, and then just press Ctrl+V. It will paste our new folder path which we create inside our repository, and we copy paste the path. Copy path, and then we just paste it here. You need to simply remove the old path from images and then press Ctrl+V. It will paste our new folder, new images folder path. Then just click on save. And here, as you can see, because we are going to create Arduino board images, so I have mentioned here Arduino_Uno. This is what our images name. Let's just say here you have ESP32. So just mention like this way, ESP32. Then the images name will be ESP32 and .jpg is the extension. So right now we capture Arduino Uno board. So Arduino Uno. Arduino Uno is my images name and .jpg action. So just click on save. Now if you start the code, you need to simply show the Arduino Uno board in front of your USB web camera and move the board in different angle. Slowly it will capture 30 images. Simple. So let me start the code. Oh, I forget to install here OpenCV, because this is the Python 3.11.2 version where we not install OpenCV-Python. We install OpenCV-Python inside our virtual environment for Python 3.9.12. So for default version, we want to install OpenCV-Python. It is really simple. Go to the tools, manage packages, search for OpenCV-Python, hit enter. OpenCV-Python, click on install, and now it will install OpenCV on our Python 3.11.2, which is our default version, not for Python 3.9.12, which is our virtual environment version for Google Color USB. Simple. So it will take some time. Meanwhile, I will pause video. So friends, we successfully installed OpenCV-Python for default version, which is Python 3.11.2. So let's just close it. And friends, here I have made some mistake. So here it is, as you can see, the path which we mentioned, the folder name is images. So if you open our folder which we just create inside our home Pi TF Lite Coral USB custom main, we create images folder, and here for the path we mention the folder name image. So here we want to mention S. I have mistakenly mentioned image folder, so folder name is basically images. Done. Now we are ready and we are going to capture our Arduino Uno board 30 images. So let's just start our code. So as you can see, we capture our Arduino Uno board images. So if you go inside images folder, and here it is, we have 30 images. Right click, image viewer. So we want to simply move our object in front of the camera in different angles slowly. Here it is, as you can see, we have images. Now we are ready and we are going to open our label IMG software. So minimize Thony, open terminal. As you can see, there is no virtual environment because we are going to create our own custom model. So for creating own custom model, there is no need to activate the virtual environment. Simple. So just run here label img command, label img, and hit enter. It will open our software and just make like this way. Okay, now minimize the terminal. This is what our label img software. Go to the OpenDIR Pi, scroll down our repository. Inside that we create images folder, and inside that we have our all the images, as you can see. And then change save dir, go to the Pi, scroll down, again same repository and images folder, click on choose. Now we are ready, and let me make more bigger like this way. If you go previous image, next image, previous image, now it's perfect. Simple. Now Pascal VOC for TF Lite version, and now we are ready, and just click on create rectangle box and draw the rectangle box on our not ESP32, on our Arduino Uno board. So draw the rectangle box like this way and mention the object name, which is Arduino Uno. Arduino Uno, save the image, go to the next image, create rectangle box, draw the rectangle box, click on OK, save it. So here, as you can see, we want to mention here a Pascal VOC. Don't change with YOLO. We need here Pascal VOC. Then just create rectangle box, draw the rectangle box, and then just save it. Go for next image, create rectangle box, draw a rectangle box on our object, mention the Arduino Uno, which is our class name, click on OK, then save it. Now if you open file manager, repository, images folder, we have our image, their XML file, image, their XML file, image, their XML file. So we successfully creating XML file for our images. So let me draw a rectangle on all the images. Meanwhile, I will pause the video. So friends, I have done with drawing rectangle on each images. Simple. Now just close label img software. Now if you open our repository, so just open file manager. This is what our repository, where we create our images folder. So inside that images folder, as you can see, we have image, their XML file, image, their XML file. For each image we have XML file. Done. Now just go back and here create inside repository where we create images folder. So here again create a new folder which is Freedom Tech. So right click, new folder, Freedom Tech. This is the folder, Freedom Tech folder, and go inside Freedom Tech folder. Here create a new folder which is train, and then the next folder, validate. Simple. So inside our repository we create images folder where we capture our images with the help of our USB web camera. Then we train our images with the help of label img software. And now again in same repository create a Freedom Tech folder, and inside that folder we need to create train and validate folder, train and validate. Now inside this train and validate, just copy all the data from our images. So just press here Ctrl+A, and then copy it, go back, Freedom Tech, train, just paste it, Freedom Tech, validate, just paste it. Done. Now we are going to create this Freedom Tech folder as a zip file. So minimize our repository, and then, or let me mention, I have mentioned the command here. So open rpi4.txt as a text editor, and inside that text editor I have mentioned the command which basically create a zip file. So this one command, sudo zip -r, just copy the command as it is, copy it, minimize text editor, minimize all the things, and open our terminal, clear the screen, and here it is. As you can see, I am now inside our repository which is TF Lite -Corer USB custom main. This is what our repository. If you run here ls command, so we have here Freedom Tech folder. Inside that we have train and validate folder, and inside that we have all the data. So we are going to create this folder as a zip file. So for that we copy our command from rpi4.txt file, the second command, so just paste it and then just hit enter. It will create our zip file. So open our repository and we have, here it is, we have our freedomtech.zip file. Now we are going to upload this file on our Google Drive. So let me open my Google Drive. So friends, as you can see, I have opened my Google Drive and just click on new and upload our freedomtech.zip file. So file upload and then go to the home, our repository, and we have here freedomtech.zip file. Click on open. Now it will upload our freedomtech.zip. As you can see, it's upload our file on our Google Drive. So meanwhile we are going to upload our Colab file. So just open Google Colab, go to the upload, click on browse, go to the home, our repository, and inside that I have mentioned our Colab file. So just select it, click on select, and it will upload our Colab file on our Google Colab. So friends, we successfully upload our Colab file. So let's just go here, runtime, then change runtime type and just select Python 3 and select T4 GPU. Click on save button and then just click on connect. So it will connect. So friends, as you can see, we successfully connect with T4 GPU. Now we are going to run our cell one by one. So just click on first cell. Just click on first cell. So basically we are going to activate here virtual environment. Simple. So then our second cell, so just click on second cell and now it started our second cell. So if you scroll down for second cell, we need to mention here a permission. So basically we want to press the Y from our keyboard. So second cell is basically running. As you can see, the process is started. So here if you scroll down, here it is. As you can see, for second cell, for proceeding, it says we need to press here Y or N. So of course just click on here and press Y from keyboard and hit enter. Then it will start our process for second cell. As you can see, now it started our process. So friends, we have done with our second cell. Now third cell, so just click on third cell. Done. Now fourth number, conda create Python 3.9. So just click on the cell, this one, conda create my environment Python 3.9, and for this cell also we want to mention here proceed yes or no. So just click here, press Y from keyboard and then hit enter. Then it will start our process. Done. Now next cell, just click on it. It will install TF Lite model maker process and it will install TF Lite support packages. Sorry, not process, basically it will install TF Lite -model maker package and it will install TF Lite -support package. Simple. So it will take some time. Meanwhile I will pause video. So friends, we have done with installing TF Lite model maker and TF Lite support cell. Just scroll down, go for next cell, just click on it and it will start the process for next cell. So as you can see, we have done with this cell also. So just scroll down and run the next cell, which basically install OpenCV Python for virtual environment. Done. Scroll down, go for next cell, it will install NumPy. Done. Scroll down, go for next cell, done. Now we have done with all the installation packages processes. Now we are going to simply mount our Google Drive. So meanwhile, first let's just cross check our file is uploaded. Yes, we successfully upload our freedomtech.zip on our Google Drive. So now we are ready. We can simply mount our Google Drive. So let's just start our cell. It will ask the permission. Here it is, as you can see, permit this notebook to access your Google Drive files. So click on connect to Google Drive and select your Gmail ID which you use for uploading the freedomtech.zip file on your Google Drive. Select the same Gmail ID. So mine is freedomtech, this one. Select it, then click on continue. Scroll down, just scroll down and then click on continue. Done. Now it will mount our Google Drive on our Google Colab machine. So friends, we successfully mount our Google Drive. Now just scroll down and next cell, unzip freedomtech.zip file. It will unzip our freedomtech.zip. As you can see, inside that we have Arduino Uno XML file and JPG image file. Now just scroll down, and now here we want to start our training. So for that, first we need our train.py. So just click on this folder icon here, click on it, and then just click on this upload icon, just click on it, go to the home, our repository, and inside that we have train.py file. As you can see, train.py, select it, click on open, click on OK, and it will upload our train.py on our Google Colab. So we have done, as you can see, we upload our train.py. So just double click to train.py, it will open our train.py here. Here it is, as you can see, and here we have object. Here we want to mention object, and here also. So here it is, as you can see, by default I have mentioned two classes for two objects. So right now we have only one object, which is our Arduino Uno board. So just remove one from here. So remove this one class name, and now our class is basically not helmet, our class is basically Arduino Uno. So remove the helmet and mention the new object, which is Arduino Uno. Same for here, remove the safety jacket, because we have here only one class, we have here only one object, which is Arduino Uno. Remove the helmet and mention the Arduino Uno. Arduino Uno, done. Arduino Uno. And if you scroll down here, just scroll down, this is the model which we are going to use, and here model is equal to object. If you just skip the line like this way, here it is, as you can see, I have mentioned here 100 epochs. Done. Now just press here Ctrl plus S and just save the train.py file. We are ready, close it, and now we are going to start our training. So just run the cell, which one? This one, where we have train.py, this one cell. Run it. Now it will start our training process. Just watch. So friends, as you can see, the process is started. It started our first epochs. So it will take some time. Meanwhile, I will pause video. So friends, we completed our training process and we create our own model best.tf Lite. So this is the model which we use for TF Lite version. This is only for TF Lite, not for Edge TPU. So we want to compile this best.tf Lite, our custom model, with Edge TPU compiler. For that we have here next cell, as you can see. So just click on this cell, it will install Edge TPU compiler on our Google Colab for virtual environment which we create here. So it's processing this cell, as you can see. Done. Now just scroll down, and here it is, as you can see, this command Edge TPU compiler, and this is what our model which we create, best.tf Lite. It will compile our default model best.tf Lite into Edge TPU format. So run this cell. There is no need to change anything. As you can see, I have mentioned the model, our model name already there, so there is no need to change anything here. So just run the cell. Done. Process is done. Now here it is, as you can see, we create best Edge TPU.tf Lite model. This is the model which we compile for Edge TPU TF Lite. Now last process here, if you scroll down, last process, we need test.py. So again, just go here, click on this upload icon, go to the home, our repository, and inside that we have test.py code, test.py. So just click on open. It will upload our test.py on our Colab file. Here it is, as you can see, we upload test.py. Just double click, and this is the code which basically we are going to use for metadata. So inside that I have mentioned all the changes, so there is no need to change anything from test.py. Just close it, the file which we upload test.py, and just run the cell, our last cell. Just click on the cell, play button. Done. Now we have completed our all process. We have our own Edge TPU.tf Lite model. So this is the model, as you can see. Just click on this three dot icon, click on download button, and it will download our model. As you can see, now it's downloading. So friends, as you can see, we successfully download our model. So minimize all these things and open our file manager, go to the home, go to the downloads, and this is what our custom model for Edge TPU TF Lite. So we want to move this model inside our virtual Freedom Tech directory. So right click, click on cut, go to the home, and we have here our virtual directory Freedom Tech. Inside that we have Freedom Tech Lite Bullseye main folder, then we have examples folder, then we have Lite folder, again examples folder, then we have here object detection folder. Inside that we have Raspberry Pi, and here we want to paste our model best Edge TPU.tf Lite. Right click to the model, rename, and copy the full name, copy it, cancel, and close all the things. Now just open our Thony Python IDE which we have already opened, close img.py, and again now we want to change our Python version. So go to the run config interpreter, select here home Pi Freedom Tech VNV bin Python 3.9, our virtual environment with Python 3.9.12 version. So go to the file, click on open, go to the home, our virtual directory which is Freedom Tech, TensorFlow Lite Bullseye main, examples, Lite, again examples, then go to the object detection, Raspberry Pi, and detect.py, not detect1.py, remember detect.py, click on OK. So this is what our code. So we mention here our default model, so we want to simply change the name with our own custom model. So our model name is over here. As you can see, this is our default model. So we want to mention here our own custom model which we copy. Just press Ctrl+V. We paste our model name. save it. If you go here, what we have done, we just go inside Freedom Tech folder, we download our model, and our model is basically inside downloads. Then we just cut paste the model, we go inside our virtual folder Freedom Tech. Then we have TensorFlow Lite Bullseye main, examples, Lite, examples, then object detection, then Raspberry Pi, and we just paste our model, our custom model. Then right click, rename, copy the name, copy it, and just paste the name inside our detect.py. Just replace the name with default model, best Edge TPU.tf Lite. Now we have done. I have connected my USB web camera, just run the code. As you can see friends, it started our web camera, and if I show Arduino Uno board, it's detecting Arduino Uno board. As you can see, it's detecting Arduino Uno board with the help of Google Coral USB. It means we successfully create our own custom object detection model with the help of Google Colab for Google Coral USB Accelerator with Raspberry Pi, latest Raspberry Pi OS Bookworm 64-bit version. So I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.